So Leetcode problem of the day, and here we come up the solution for the problem called build array, where you can find the maximum exactly k comparison to find the largest element. So this is the hard level question. So I'm going to explain this question in 2 steps. So I highly recommend you to watch till the end of the video so that you can come to know the detailed solution for this problem. So let's check out what does this problem says that. So we have given three integer n, m and k. So what does this n, m and k says that? N is nothing but that will be the size of my array. M is nothing but the elements which I am going to insert in my array that should lie in the range of 1 to n. Right, say for example I have 6, so I can insert the element in my array from 1 to 6 any number of times. I cannot insert an element beyond 6. And what does this k means? Let's understand over here. So they have given one algorithm for us where we are supposed to find the maximum element in my array. So what they do is, whenever we are searching for the maximum element, our cost will get incremented by 1. Say for example, in this example, the maximum element is 6, right? So I'm starting with 2. So is it a max element? No. So my cost increases by 1. Now I come over here. Is my 4 my max element? No. So my cost get increases by 2. Now I come across over here. Is the 6 my max element? Yes. So my cost again increases by 1, because when I checked over here, then I came to know that this is the maximum element. So its total cost is 3 in order to get the maximum element. So this is what they have mentioned is this will be the total cost you will get to find the maximum element. And finally what they have told is we need to build array such that my size of array will be n, elements in my array will lie in the range of 1 to m, and the total cost to search the maximum element will be exactly k, right? Say for example, if I place this 6 over here, and say for example here I got 1, is it a valid array? No, because the total cost to find the maximum element is 3, but here how much it taking? 1, 2, 3 and 4. We are going beyond k, so this is not a valid array. So I hope so you understood the meaning of the question. This is bit difficult part because itself is a hard level question. So let's understand the intuition to solve this question. So let's have the intuition to solve this question. I highly recommend you, these are the most important point to solve this question. So please do watch this video till the end so that you can come to know the clear idea to solve this question. So the first point is how many elements we have placed in the array so far. So how we will come to know that how many elements my array has, because in the question they have stated that my size of array is n, right? We cannot exceed the size of my array beyond n. So say for example this is my array of size 5, 1, 2, 3, 4 and 5, and this is my index, right? And so far I have inserted elements 7, 6 and 3, and now currently my index is pointing at position 3. So from this, if my index is pointing at position 3, can I say the total number of elements in my array is 3 itself? Because here you can see 0, 1 and 2. So there are 3 elements I have inserted in my array since my index is pointing at position 3 itself. So I hope so you got to know how we can come to know that how many elements my array has inserted before inserting this element. Or can I say that if I'm standing over here, if I want to know how many elements my array already contains, so can I say the 3 elements can I say? Right, say for example if my index is pointing at position 4, so how many elements they have already filled? Can I say 4 elements is already filled? Because if my index is pointing over here, it might contain one, say for example 7, one more again here. So there are total 4 elements my array contains since my array index is pointing at position 4. So here you can say that there are total 4 elements already filled. So from the variable index we can come to know that how many elements my array contains. So I hope so you got to know the first point, that is how many elements my array contains so far. So now let's move on to my second point, that is a maximum element in my array. Now the point is, why do we need to know or why do we need to store the maximum element of my array? The reason for this is my third point is totally depend on my second points. This is how we will look after laterwards when we discuss the third point. But let's now discuss how we can come to know or how we can store the maximum element in my array. Say for example, I got an array that is 1, 6 and 4. So which is a maximum element in my array? For sure the 6 is my max element, right? So how can I come to know that which is the maximum element? So what I can simply do is, say for example right now my array is empty, so my max element initially is 0. Now what I will do is, now say for example I have inserted 1, so I will compare this element with my max. Is it greater than max? Yes. So I will simply put over 1. Now say for example again I inserted 6. Now once I insert a 6, I will check, is the 6 is greater than my max? 1. Yes. So I will simply update it to 6. Now say for example I insert 4. Now we'll check, is it 4 greater than 6? No. So my max remains 6 itself. So this is how we will keep a track of the maximum element, and this is a really important point because my third point is dependent on my second point. So I hope so you got me how to know which is the maximum element in my array. So now let's move on to the most important point, that is the how many new maximum element we can insert in my array, and this is the most defining part I can say. So let's check this point in more detailed way. Okay, now let's discuss one of the most important and defining point of this question, that is how many new maximum element I can insert in my array. Say for example, I have given an array which is size of 6 and I can insert the element in the range of 1 to 8, and k is my total cost where I need to get to find the maximum element. So there are basically 4 elements in my array, 4, 5 and 7. So which is the current maximum element? 7. So in order to get this maximum element, what is will be my total cost? Because say for example, I'm starting from this. So if I'm at 4, my cost increases by 1. Now I got 5. I check, is it 5 is greater than 4? Yes. So my cost increases by 2. I come at 7. I check, is it 7 is greater than 5? Yes. So 7 is my greatest element. So now total cost to find the largest element is my 3. So can I say that from 4 my k has come across to 1 because the remaining cost is 1. So I can say in this remaining part still I can insert one element which is greater than 7, but I need to put it in exactly at this place, because if I place 8 over here, what will be total cost to find this maximum element? 1, 2, 3, 4 and 5, which is exceeding the 4, so this is the reason why I need to put 8 over here so that I can get the maximum element at exactly 4 steps. So this is the reason why I need to know, should I insert over here maximum element or should I insert a minimum element over here? So how can we decide whether to put the max element or whether to put the min element? So it's totally depend upon my value of k. So far my value of k is 1, which means still I can insert one maximum element greater than 7. But only a thing is I need to put exactly at the adjacent of 7. So which is a maximum element which is greater than 7 and less than equal to 8. For sure I can simply put here 8 only, right? So I can simply insert 8 only. So in order to get the maximum element, my total cost will be 4. So exactly at 4 step I can get this maximum element, right? Now say for example, my value of k is 3. Now here we got the maximum element as my 7, right? So I got the max element as 7. So my k is equal to 0 now, because it's total took 3 costs to find this element, that is 1, 2 and 3. So value of k is my 0. So now the point is, can I insert a maximum element over here? Absolutely no, because my value of k is itself 0. So why should I waste my cost to search the maximum element beyond this number? So anyhow I need to insert elements over here which is a less than 7, So I hope so you understood how to decide whether to put the max element over here or whether to put the min element at the remaining places. So now let's check out these two possibilities, whether to decide max element or min element more clearly. So this is a question mark. As I mentioned earlier that we have the two options, that is either we can insert max element or we can insert the min element. So how we can find which is the possible way? Since we have the two option, and as I told you, whenever we get an option, which data structures or which technique comes in our mind to implement this? For sure recursion. So recursion will help us to find a number of possible ways whether to insert minimum element or whether to insert maximum element. Now let's first decide a minimum element, right? So first we will try to insert a minimum element. So till this point my maximum element is my 7. And say for example at this point my value of k is equal to 0, which means at remaining position I cannot insert a maximum element which is greater than 7, right? So I have to insert a minimum element itself. So what are the possible ways, what are the possible numbers I can insert over at these three position which is less than 7, So can I say there is one thing is for sure, my array can contain a number from 1 to m, right? And so far my maximum element is 7. But the point is at this remaining position I cannot insert a number which is greater than 7. So one thing I can come to know that the minimum elements which I can insert is from range of 1 to max minus 1, right? Because my maximum element is my 7. So 7 minus 1 will be 6 and my minimum elements will be 1. So in the range of 1 to 6 I can insert any number at this 3 position. Because at this position my value of k becomes 0, so I cannot insert any maximum element over here, otherwise it will exceed the k. So I have to insert a minimum elements at this 3 position. So only the things or only the number I can insert will be in range of 1 to 6 because 7 itself is a maximum element. So I hope so you understood the first option, that how to insert a minimum element over here. Now let's check how to insert a maximum element. Now say for example my value of k is not 0. Now say for example my value of k is my 2, which means at this remaining position still I can insert 2 maximum element, which means so far my maximum element is my 7, right? My max element is my 7, but still I have the value of k as 2, which means I can insert a number as 8 or I can insert a number as 9, right? Which means apart from 7 still I can have two bigger numbers which is greater than 7. So how we can come to know that what are the possible ways to insert the maximum element? So again, as I told you that I have the options to insert element in my array, that is will be in range of 1 to m. So I got a max element as my 7, right? Max element as my 7. So I need to insert element which is greater than 7 at this position. So for minimum range, we come to know that from 1 to max minus 1. So can I say for maximum element it would be max plus 1 to m. This will be range for this position to insert a maximum element which is greater than my current max, because still my value of k is not 0. So I hope so you understood how to decide whether to insert a minimum element or to maximum element. And if you're putting the minimum element, what will be its range or what are the possible ways to insert a number that will be in range of 1 to max minus 1, because anyhow I need to insert an element which is less than 7. And if I want to insert a maximum element at this remaining position, since my value of k is still not 0, I simply need to add a number which is greater than max element and up to m, because my array itself contains a number in the range of 1 to m itself. So I hope so you understood this clearly, how to insert a minimum number or maximum number and what are the ranges we can insert a number in between them. Now let's try to design the pseudocode for this algorithm. Let's try to design the algorithm for our question. So as I told you, index will be the variable which will help us to track how many elements my array initially contains. Now max contains tells us what is the current maximum element, and k, that is how many maximum element we can insert in my array. So initially my index is 0, which means my array does not have any elements, and also max is initialized to 0, which means my array does not contain any maximum element. So what I will do is I will simply design a function, say for example fun, which takes index and is taking as max, and it is also taking as n and m, right? So what I will do is, say for example I'm over here, initially I got 7 number over here, and so my index get 1 and my max get 7. Now how many possible ways I can have to insert element over here? For sure there are the two possible ways, that is either I can insert minimum element or I can insert a maximum element. So why should I try both, right? I can try both. So what I will do is I will simply put maximum element, minimum element, maximum element, minimum element, max, min. So in this way I will try to put both the numbers at this given location. So simply what I will do is I will simply run a loop. So say for example I want to insert a minimum number here. So what I told you, in order to insert a minimum element I have the range from 1 to max minus 1, and in order to get the maximum element I have the range from max plus 1 to m. So let's try to put a minimum element over here. So simply I will run a loop from I equals to 1 to max minus 1, right? And simply what I will do is I'll simply put, say for example answer, and I will try to add this. So I do answer plus, again I'm going to call the function that's fun, and what I will do is my index will move ahead because I have inserted element over here. So simply I will do index plus 1. Now the question comes, so max is changed? No, my max is not changed, because what I'm doing here, I'm putting minimum element. So if I'm inserting minimum element which is less than my current max element, will my max updated? For sure no. So my max remains the same. And will my k change? No, because I'm inserting minimum element, it will not change. So k remains the same. So this is for the minimum, this is for the minimum. Now let's try to insert a maximum element, because since we have the two options we can try both the options, right? So for maximum element I have told you from max plus 1 to m we can go. So again simply we will run a loop, that is from for max I equals to max plus 1 till m we can go. And again what I will do is answer is equal to answer plus function. Now again I'm inserting the element, so my index will move ahead. Now my max, will my max change? Yes, it might change or might not change. So I'll simply keep the max as it is, because recursion will take care of itself. My recursion will take care of itself. Now, will my k change? Of course my k change, because what I'm doing over here, I'm inserting a number which is greater than my max element. Because what is the range for max element? Max plus 1 to m. So my k can change. So simply what I will do is, for k I will do k minus 1, and this will I will do, and finally what I will return, I will finally return the answer. So this is the two options we got to inserting the minimum element and maximum element. Now question comes, what will be the base case? Let's try to understand. Now say for example my value of k equal to 0. Now this is my one case, and say for example my index has reached to n, which means I cannot insert elements beyond n, because n, what does it say, that size of my array. So can I say if my index is equal to n, I need to stop. But the point is, when should I stop? If my value of k equals 0, which means we got a perfect array, because as we mentioned earlier that we can check over here, if you are exceeding the k, it is invalid, but if you are finding the maximum element within the k equals to 0, which means it is valid. So can I say, if my index is at last position and if my value of k equals to 0, I will simply return as 1, because I got one array. Otherwise I will return as 0. This is my first best case. And what if my size of k becomes less than 0? Then again it is also the invalid. So again what I will have, if my k is my less than 0, again simply return 0, because that is not a valid array. So I hope so you understood this pseudocode for the algorithm. This is the recursive way. This is the base case we did, because my size of array cannot be greater than n. If you are moving to the last index, I will check if my value of k equals to 0, which means we got the maximum element exactly at k cost. So I'll simply return 1, because I got the one array, right? We need to find the number of arrays. So we got one array. If my value of k is not equal to 0, then we haven't built that array. So I'll simply return 0. And if my value of k is less than 0, which means you are exceeding the k, we are putting more maximum element than k. So again, it is not a valid array, so I will return 0. And this is how we find the minimum element, and this is for maximum element. And as I mentioned over here, for minimum element, range will be in between 1 to max minus 1, and for maximum element, range would be max plus 1 to m. So I hope so you understood this pseudocode. Now let's check the Java and the C++ code. So this is my CPP code and this is my Java code. You can check according to your own convenience. So what we did is we simply implemented recursion. Only thing is I use the DP so that we can optimize, since it can contain the overlapping subproblems. So the first base case, as I told you, if my index reaches to my final position and if my value of k is 0, I will simply return 1, because we got one valid array, right? One valid array. If it is not equal to 0, it means we haven't got any valid array. If my k is less than 0, which means we are exceeding the length of k, I will simply return 0, because it is an invalid array. And this is for inserting the minimum element, right? This is for inserting the minimum element. Here we can say that answer my index plus 1, because for that particular position, for this particular position, I have inserted the element, so I need to move ahead. So I incremented my index. Is my max changed? No, because I'm trying to insert a minimum element which is less than my max. So my max remains the same. And my k will not change, because what is happening, say for example this is my maximum element, whatever the element I am trying to insert over here are less than k, so less than 7, so my k will never be changed, because beyond 7 there is no any maximum element. Again this is for the max element, right? We need to insert a maximum element. So what we did is, say for example I got an array 8, 9 and 10. Say for example we got an array as 8, 9 and 10, and there are still 2 positions are left, so we need to insert 2 more elements. So I have the option to put the maximum element. So max element is my 10, so I can insert element in between 10 to m, any number at these 2 position, right? So same thing I did. Since I inserted element, I moved ahead. Now max element might change, because which maximum element I'm inserting, that will get changed. And again my k will decrease, because what I'm doing over here, say for example 8, 9 and 10, so again I'm going to insert 2 more maximum elements. So my k changing, because we are going to insert an element which is bigger than 10, so my k simply decreases by 1. And finally we return my answer, but before returning we simply store it in a DP, so that we can avoid calling the extra function call. So I hope so you understood this question really well. This was the most interesting question I came across. If you want to know more about such coding, do subscribe the Runtime.